Alright, so today we're going to talk about acids and bases. Some general properties of acids. They taste sour. When I think of an acid, a good example of an acid would be a lemon. Lemons have a really sour taste. Anything that's citrus like oranges or even apples, a sour Granny Smith apple. Sour Patch Kids are great examples of something that would be an acidic, something that would have that sour taste. They turn litmus paper red. So if I put blue litmus paper into an acid, it's going to immediately turn red. If I took red litmus paper and put it into an acid, it's going to stay red. It reacts with active metals such as iron and zinc to form a gas. We did this in House of Fire when I actually put the zinc, mixed hydrochloric acid in there, put a balloon over the top, and the balloon blew up. And then we took the balloon and hung it from the ceiling and made a big fireball. All right, that was actually acid reacting with a metal. Anytime the acid is, or the metal is put into the acid, it starts forming bubbles or a gas. That's one of the ways that you can tell that a reaction has taken place. And finally, if we add phenolphthalein to an acid, it's going to stay clear. It doesn't change colors. So that's an indicator. Phenolphthalein is an indicator. It doesn't change colors, therefore we know that it's an acid. Bases, on the other hand, instead of being sour, they're bitter. They got a very bitter taste. If I put litmus paper in there, it does just the opposite of an acid. If I put red litmus paper in there, it turns blue. If I put blue litmus paper in there, it stays blue. So bases are blue as far as litmus paper is concerned. You get a soapy feeling when we're talking about bases. Actually, soap is a base. It's fat and a base put together that gives it that basic feeling. It feels slippery. And finally, it will react with acids in something that's called a neutralization reaction. A neutralization reaction is one in which an acid and base come together and you form a neutral solution. The last thing is it turns phenolphthalein pink. All right? Whereas the phenolphthalein stays clear in an acid, you'll know for sure you got a base if you put phenolphthalein in it and all of a sudden you have a pink solution. Here's an example of a piece of litmus paper, blue litmus paper, that was put on top of a lemon. Notice the end where it was actually touching the lemon or the lemon juice turned bright red. Right? That indicates the presence of an acid. The pH scale is a measure of how acidic or basic a solution is. Let me move out of the way. It ranges from 0 to 14. All right, with 0 being very acidic and 14 being very basic. The middle of that, 7, is considered neutral. So if I have anything that is above 7, that's considered a base. Anything below 7 is considered an acid. So if we just look at the scale and some of the common ones you see, all right, we have water, which is at 7. All right, milk, surprisingly, is an acid. All right, it's about 6.5. It's not a very strong acid. Bananas are acidic. Okay, even though they have a sweet taste, not sour, they're slightly acidic. Tomatoes are acidic. Apples, vinegar. Notice we get around 2.8, and then down to a lemon at 2. Hydrochloric acid is around that 0 mark. Going the other way, blood is basic. You'd think your blood would be neutral, but it's not. It's basic. Baking soda is around 8.5. Soap is around 10. On your body, what happens is when you sweat, you become slightly acidic. Your skin becomes acidic. All right, and so by adding that base, a neutralization, when you take a shower, a neutralization reaction is actually taking place on your skin. All right, and then the strongest of the bases we have is sodium hydroxide. Sodium hydroxide is would be like drain cleaner. Okay, a change in 1 pH unit represents a 10-fold change in the acidity of a solution. For example, If a solution has a pH of 1 and a second solution has a pH of 2, the first solution is not twice as acidic, it's actually 10 times more acidic. Okay? So if I had something that had a pH of 3 and I had something else that had a pH of 4, the 3 is actually 10 times more acidic than the 4. Okay? If I have something that had a pH of 2 and I had something that had a pH of 4, it would be 10 times 10 or 100 times more acidic. So the pH scale, when you think about it, when you see something that, when you're comparing a pH of 1 to a pH of 2, there's a great range in difference there. Here are some common acids. We've talked about naming acids earlier. Okay, if you remember, if you have a binary acid, you're going to add the prefix hydro, IC, and the word acid. So here's a binary acid made up of just two different elements, hydrochloric acid. All right? Notice this one's made up of 3 different elements, so it's not going to be the same. Okay? You drop the hydro, still add the IC and acid, so this is nitric acid. Again, not a binary acid, so you have phosphoric acid, and still not a binary acid. It's sulfuric acid. Notice all 4 of these start with hydrogen. Hydrogen is what you look for when you're naming an acid. That's what we need to see. If you're given several different substances and said which one is the acid, the one that has hydrogen as the first element is going to be your acid. Okay? Whereas acids have hydrogen, bases have hydroxide. Right? Notice the first one, sodium hydroxide. That's one of the strongest bases. Potassium hydroxide. What's the third one? That's right, barium hydroxide. Next one, magnesium hydroxide. And finally, aluminum hydroxide. Bases have hydroxide. That's how we're going to know, that's how we're going to recognize them, especially on the OC. Okay? Here's a few I want you to try. See if you can check. Just pause the tape, go through them, and then we'll go over the answers. All right. The first one, it's got hydrogen, so it's an acid. The next one, hydroxide's at the end, so that's a base. Leads with hydrogen, that's an acid. That's sulfuric acid. The next one, hydrogen, so that's hydrochloric acid. And the last one, sodium hydroxide, has the hydroxide, so it's a base. All right, the last thing we're going to talk about is titrations, and we're going to do titrations in the lab next week. A titration is just where you take an acid and a base together, and you want to get to the point where they're equal, where you have equal amounts of acid and base. We'll talk about molarity later on in the week, but by doing this, we're able to figure out the molarity of an unknown solution. We'll know the molarity of one of the solutions, and the other one we're trying to find out. Just a simplified way of doing it. If you look on the screen, you'll notice that this is an acid in phenolphthalein. The acid is clear when it's in phenolphthalein. The base, go back. The base is pink. So a base in phenolphthalein is pink in color. Right? When performing a titration, the first thing you want to do is measure the level of the fluid in what's called the burette. That's this tube, the burette. Okay? Notice that she's put a piece of paper up behind the burette. We're reading what's called the meniscus. Okay? And the meniscus is this point right here, the low part. Okay? We're reading the bottom of the meniscus. By doing this right here, by putting the paper in front of it, she's able to see that meniscus. Sometimes you can't see it because of the background. All right? And that gives me a solid background to be able to take a reading from. We're going to read and record the measurements to 2 decimal places. Okay? It's very important because these calculations that you're going to make are small increments. You've got to be able to tell the difference. Okay? You got to be able, a half a milliliter makes a huge difference. All right? So this is 24, this is 25, so that would make that 24.1, 24.2, 24.3. Notice it's not all the way to 0.3. All right? So what I want to do is I want to say it's 24.2, and then I got to make a guess. That's where my second decimal place comes in. I'm guessing 0.8 on this. So 34.28 would be my last estimate. Alright, so then what I'm going to do is I'm going to get my solution, what I'm going to know as my known. This is the solution I know the molarity of it. Okay, I know how much I have in there, and I'm going to add 3 to 4 drops of phenolphthalein. Alright, my solution in this is going to be acidic, so it's going to stay clear. Alright, then I'm going to add drop by drop the solution, probably a little bit at a time, maybe a milliliter at a time, till I start seeing this. You should see this start to change colors. As it nears the end point, it's going to change and stay a color. So it may start out pink, or it may stay out clear, and you'll see pink coming in there. You swirl it and disappear. You keep swirling it and swirling it and swirling it until it gets to the point where it doesn't stay it starts staying, for not disappearing. Okay, when you're near the end point, okay, that's the point where it starts not going away. You want to start adding it a drop at a time. Alright, because one drop can make a big difference in these things. When you get to where it's staying and it's not disappearing hardly at all, you're having to slosh it a lot in order to get it to disappear, then you want to do what's called a half drop. Half drop means you get the drop at the end, put it against the side of the thing, just let whatever's in there across the, and then wash it with distilled water. It'll go in there, and you should see eventually it'll turn pink. Okay, this is what we're looking for. Notice hardly any color at all in this. All right, very slight pink. So that's when your titration's over, when you get to that point. All right. And then all you do then is read your bread again. It's important that you read the bread at the beginning and read it at the end, and you put down the best measurements to the best of your ability. My suggestion is you have 2 to 3 people in a group. Make sure it's not that you're not the only one who is doing that. That someone else in your group is also reading the bread, so both of you can take, or at least 2 to 3 people can take ownership in that. Alright, so that's all we have on acids and bases. Remember, just a few things. If I'm looking for an acid, I'm looking for hydrogen. If I'm looking for a base, I'm looking for OH. Phenolphthalein in the presence of an acid is going to be clear. Phenolphthalein in the presence of a base is going to be pink. Litmus paper turns red litmus paper turns blue in the presence of a base. Red litmus paper stays red in the presence of an acid. All right. Hopefully everything this will do good next week when we get to our acids and base section. Everybody have a good evening. Signing out.